I hope you're having a good second day of the conference. Yeah, we can make this a little more interactive. If you've got any questions that you want at any time, just stick your hand up and ask them. It doesn't just have to be me standing out the front reading my slides. So, just a little bit about who I am. As I was introduced, my name's Justin Mclean. As you can probably tell from my accent, I'm from Sydney, Australia. And I've been involved in the ASF for about 8 years in a number of roles. I'm interested in IoT and that sort of space, and I actually started the IoT meetup in Sydney, Australia, which I've been running for 6 years now. At Apache, I'm currently the VP of the Apache Incubator. So if you are on an incubating project, is anyone here? Hey, have I voted on one of your releases?
I'm not sure.
Yeah, I probably have. And that may have been a -1 too. Nah, not all of them, but anyway. So yeah, so through the Apache Incubator, I help mentor a whole lot of projects, and we have some more people arriving, which is good. Hi, welcome. Come down the front, grab a seat. We've only just started. So yeah, and I mentor a whole lot of other projects, and I'm self-employed. I work for myself, and I've done so for about 25 years. So I don't work for any big companies or anything like that, but that gives me the chance to work on a lot of many and varied things. So anyway, Apache Mynewt is what we're talking about today, and that's decided not to work. That's fine. So Mynewt is a bit of a play on words. Mynewt means small. And it also has the salamander, the newt lizard, that's there as part of its logo. Oh, okay, got more people arriving. They've found where it is. Welcome. So just an overview of what Mynewt actually is. So it's a real-time operating system, and I assume everyone here knows what they are. You probably wouldn't be at this talk if you didn't. And it's for low-powered constrained devices. So generally 32-bit chips. Think of it as Linux. Oh, okay. You went to the wrong one. So you can think of it as a framework that gives you Linux-like features on devices that can't actually run Linux. And in the sort of embedded space, there's sort of two classes of devices. There's ones which you have plugged into the power all the time, or have decent batteries, so they don't have to. And then these other ones that are usually the sort of the more, I guess, dumb sensor types that you leave out in the field for 6 months. And with those, the battery life is a very big consideration, because you often don't have means to recharge the battery or replace the battery or whatever So it can't just run for a couple of hours and then be flat. So Mynewt is sort of aimed more at that space, and we'll get into some of the reasons why and the details there. It is a permissive open source license, and at the time when the project came to Apache, that was quite new. There are other real-time operating systems around, but they were generally under the license of, here's one you can use for non-commercial projects, and that's free. And if you want to use it for a commercial project, then you've got to pay for it. So this is one of the reasons why this program exists. It's also been designed from the ground up to be cross-platform. Some of the other RTOSs have evolved over years, and they've sort of built layers upon layers upon layers and done other different things to make them work on different platforms. If they do, some of them don't. And it's been built in from the scratch, and they've put a lot of thought into that. The other thing is that security is not an afterthought. It's been built in from the start as well. Unlike some of the other RTOSs, that security has been added afterwards, sometimes to good effect and sometimes to not. And it's got quite a simple programming model. It's not horribly abstract. So you can get used to it straight away and get things happening. And I'll show you some code examples so you can see what's going on. Now, when Mynewt came to Apache, they had a large number of third-party dependencies and a large number of pieces of third-party code in their software. And they were all under different licenses. Now, there's a lot of licenses which are compatible with the Apache license, like MIT and BSD, for example, are two good ones. But not all of them were there, and one of the things the project did really well was speaking to vendors and asking them to relicense their software under a license that was more permissive with Apache. And that means they could go out and use existing software that was already there, but it didn't have a compatible license until they asked for it to get changed. So everything is now Apache licensed, and it's free to use under, you can use it for just about anything. You want to use it in commercial projects, you can. If you want to use it for your own things, you can. You've just got to say that it's under the Apache license, and that's a bit it. So they had a choice of a couple of foundations they thought they might go to. At this point, the Apache Software Foundation didn't really have any IoT-style projects, and certainly did not have any embedded projects either. And there was a number of reasons that they decided to come to the ASF, and the first thing was the Apache license, and that it is permissive. It was also the way that we look at software and IP policy. We will go through and look at every single line of code and make sure we know where that came from. So they also like that you're not a company that joins the ASF, you join as individuals, and anyone can contribute and free to contribute, which is the model that they wanted, because they didn't want to end up, there was a company that donated the code base, they didn't want to be the sole owners of the code. They also liked the fact that the ASF had a very successful run of projects. We'd been around for almost 20 years. And there were 50 projects in the incubator at any one point, and most of those make it to graduate. They also like that companies can't buy board seats, that the board members are actually elected by the ASF members at large, and so that everyone gets a fair and even say. And most of all, they like the fact that it was for the public good, and that's what they wanted to do. They wanted to actually, they'd already created this software code base, and they had used it in some commercial projects, and they've made money out of it. But they thought, well, maybe we should actually, give it back and see what other people can do with it, and see what they can use. So the project went through an incubation process, and that's what almost all projects do at the Apache Software Foundation. And basically, we go through the process to make sure that everything's compatible with the Apache license, and the project operates how Apache projects should operate. There's this thing called the Apache way, and that's what they need to follow. And sometimes it takes a little while to work that out. Each project is different, and they have different challenges that they may face, and there's not always one right answer to a problem. So basically, we want to make sure that people who contribute are recognised in the project, and that all the decision making is done in the open. And we want people to act as individuals, but not as companies. There's a couple more Apache Way talks at this conference. You should go along to one of those if you're more interested in it. And if you're interested in the incubator, I'm also giving another talk tomorrow on the incubator, so come along to that. So a brief history of the project. It got donated and proposed by a company called Runtime. It entered incubation in November 2015, and it was there for about a year and a half and got voted in as a top-level project in June 2017. It made several releases while it was in incubation. That's 1.1, 1.2, 1.3, 1.4, and 1.5. And they've just recently made a new 1.7 release, and they've actually split the main project into two projects, and I'll go a little bit into that in a minute. This is the main repo here and shows the project stats over time. So you can see that it's quite an active project. It's probably not as busy as, say, Spark or Hadoop or one of those projects, but it's got a lot of contributions over time from lots of different people, and it's constantly being worked on and updated, and new features are being added as well. Sorry? I would say number of contributions a week, number of pull requests, something like that, at a guess. I don't know. I just copied it off GitHub, and I can't remember what the y-axis was. So It's a pretty graph, you know. Yeah, sorry. I'll make sure I'll put some labels on those. So, what is Mynewt, and what does it do? So it's a real-time operating system, and it's got a number of features built into it. So it has very good power management. I'll talk a little bit about that later. It has watchdog features. So this means that if you write your code and it doesn't do the right thing, and the device ends up, you know, dying or turning into a brick, the watchdog will reboot it and start it up again, and hopefully that won't happen again. You know, it's just this little extra safety thing. It takes security very seriously, and it has a secure bootloader and a secure way of updating images as well. And it's got several different mechanisms that you can use for that, and I'll go into those in a little bit of detail. It's actually quite programmer friendly in that it's very easy to debug and build, and it gives you a lot of stats and statistics and logging details about what's going on. And you can filter these down and focus on just, you know, the things that you're interested in. But that will, it makes programming it quite easy compared to some other systems. It also has a flash file system as well. So you can write files out or read files in and do all that, whatever you need there. And there's a couple of those that they've implemented. So what does the code look like? So this is a most simple, like this is sort of the IoT hello world, which is make a LED blink. So you can see there's just a main program. You can see that it's C, so that's probably the first thing. And then we've got a system init at the top to initialize everything. We then have a general purpose I/O pin, which is, in this case, a LED pin. And then we just wait for some amount of time, and then we just toggle that pin and just loop forever doing that. So that just blinks. So that sort of shows you how simple the programming model is. And like, it's not a very exciting program, just blinking a LED on and off, but you got to start somewhere. So it has multitasking built in from the start. Has anyone here used to program back in Windows 95 days? No? Do you remember non-preemptive multitasking? Yeah, there's a couple of nods. Yeah, okay. So basically, this programming style is that once a thread has control, it can do anything it wants, and nothing else gets a look in until it gives up control. So you've got to be a little bit careful in programming this way, because if you manage to put something in an endless loop, then nothing else is going to run. But it does mean that you don't have to worry about a whole lot of problems that come with multitasking. It means that you know while this bit of code is running, no other code is running. So that's actually, particularly in small constrained systems, that simplifies your architecture considerably, and it makes it quite easy. So we have basically a whole lot of tasks, and they're priority based. So there's 250 levels, and basically the highest one runs, and it will keep running until it stops running, and you put it to sleep. And then it looks at the next one, and then that will run, and so forth. The task can be triggered to run in certain ways. You can make them so that they run, say, you know, run this every minute, or run this every 10 minutes. But you can also say, when something happens, like this pin changes value, run this task. Or when we get some network traffic, run this task. And things like that. The tasks can also communicate between each other with messaging, so you can have other tasks wake up another task and make it run as well. And there's also a special watchdog task as well, so that can run when the watchdog gets triggered. All of these tasks have quite extensive debug information, and you can set the stack of each one, and you can see how much memory each task is consuming as well from the debug information, which is really, really handy. It also has stack overflow protection as well for each of the tasks. It won't save you if you do something really, really bad, but if it's just something goes slightly wrong, then the device will keep running and keep working, even though you've managed to go off the end of the stack. So this is the code to create a little task. And again, we've just got, this is just setting up the task here. So we have here a stack. You give it a size. We've initialized the GPO, general purpose I/O pin again, and then we basically do exactly the same thing. And you can just see that it's just called my task function. So you just create a function, and that turns it into a task. And then to set it up, there's a OS task in it, which you call. And you just got to pass some parameters there, including the structure that you've made for the task and the stack, and the function that you want to call. And that's basically it. So in this case, we're saying, well, we're just going to have it wait forever. So it'll be around forever. So again, this is this very simple programming model. That it's very easy to get into and not complex, and you can quite easily put a whole lot of tasks together to do what you need to do. Have any questions at this point? No? Okay, cool. So I said before that it works on a large number of devices. So there's a hardware abstraction layer that they've built in, and that's implemented for every single major chipset that it's on. And it's a standard API, so you've got just to implement the low-level bits underneath that to get it working on a new chip. So it means that if you've already got it on one family of chips, and if you want to port it to something that's similar, there's not a lot of work required. And it also means that if you are running on one platform and decide that for whatever reason that's not the hardware platform for you, you can very easily move to another one and none of your code changes. The code is all identical on the both platforms. You may have to change a few things because the hardware is different or has different features or different pins or whatever, But it's minimal work to do that. So on top of the hardware abstraction layer, there's actually drivers. And the drivers are there so that they can support a couple of features, including power management. So it means that every time you talk to the hardware, it's aware of all the power management features, and that can turn things on when they're off when they're not required, or put things to sleep when they're not needed. And then on top of those drivers is a sensor framework. So it's nice and hierarchical. It's fairly simple. It's not horribly abstract, as I said, like some other real-time operator. Who here has used, say, TI RTOS? Anyone? Do you like it? Yeah. Yes, that's my feeling too. Yeah, it's really overly complex and abstract. Yeah. Now, it works very well with the hardware it's a single vendor who makes the hardware and makes the RTOS, so they do work very well together. But yeah, trying to get your head around some of it is, yeah. I'll talk to you afterwards about it. So what boards does it support? Well, it currently supports quite a number of boards, but these are the main ones. So it supports the Cortex M0 to M4 and M7 microcontrollers. Are people familiar with those or have heard of those? A few nods, maybe not. They have general purpose, low power devices. There is the most embedded electronics these days would use a Cortex MX of something. They ship billions of them a year. It also run on MIPS and RISC-V as well. So, but there's other stuff it runs on. It'll run on STM boards, and STM chips. There's a Nucleo chips. Do you know Adafruit, Feather environment? It'll run on those as well. It runs on a whole lot of Nordic Semiconductor. There's a Bluetooth device called the Ruvi, which is quite an interesting device. It'll run on that as well. It'll run on some high-end Arduinos and Raspberry Pis and microbits as well. So if you've got a couple of those devices lying around, as most hobbyists do, then you can go ahead and start playing with Mynewt and not having to buy a new hardware platform. The main area of functionality is around Bluetooth, and it's got comprehensive Bluetooth support. It supports Bluetooth 4.2 and 5, and it supports all of those features that are there. So you can have the entire Bluetooth stack and do absolutely everything, which is a huge amount. I don't know if anyone have actually looked into the full feature set of Bluetooth. It does lots. Yeah. So, but you can just make it as a host or a controller. It will support up to 32 connections, 2 megabits per second throughput. which is pretty good. And it's totally tunable. So if there are features that you don't want, you just don't use them and they're not included in the code. And it's also portable in that you can be using, say, Nordic's Bluetooth chip one week and another one the next week, and the code's exactly the same and it all still works. So I'll just show you a little bit example of here. This is probably the most simplest Bluetooth bit of code you can get. It can be a lot more complex than this. Basically, this is just broadcasting a number on Bluetooth, and then if you put your phone near it, it would pick up what the number was. And the number is just random, basically there. So, and if I just go to the next page, yeah, oh, that work? No, it didn't. There we go. All right, so here we've got here is that we're basically creating a UUID, so that's just a random string. We're just filling it full here of 11, which is, well, we're just filling it full of a single value. And then we're setting it up as a Bluetooth beacon, and then we're just advertising that. And that's, you know, it's a few lines of code to do that. You can do more than that, but that's sort of the start of it. And again, it just shows you how simple the programming model is. There is also support for Wi-Fi. It doesn't support high-speed Wi-Fi currently, but it does have native support for TCP/IP and UDP built in to it, and it supports some of the IoT type protocols that are built on top of this as well. So CoAP, for example, is one of them. There's a couple of file systems. There's a thing called a Neutron file flash system, and it's designed to be like the standard sort of, I think FAT32 type file system, but it's optimized so that it uses minimal amount of RAM, and it minimizes disk use as well. Because you're not actually writing to a physical hard disk here, you're actually writing to a bit of memory, and most of this flash memory can only be written to a certain number of times before it stops working. They're hundreds of thousands of times or millions of times, but eventually it's going to stop working. So you want to make sure that you don't do that. They're still doing work on encryption and compression in there, but there's been some work that's been done on that. I mentioned before that there's a sensor framework that sits on top of the driver and the HAL, and that just makes things easy for sensors to work with. And we're getting people who are donating more sensors. You know, every few weeks there's someone else who comes up and says, "Oh, I've got this sensor to work now," so that makes it easy. So there's a lot of common sensors that have already been implemented. So chances are, as if you're working with an accelerometer, or you're working with, say a temperature or a pressure sensor, that someone's already written that code for you, and you can go ahead and use it. So I'll just show you what the sensor code looks like. So basically, you set which sensors that you're interested in. In this case, this is an accelerometer. That you're just saying, well, these are the types of things that I'm interested in. And then you register with that sensor, and then basically you're going to get information about it. And that's it again. Very simple programming model. If anyone has done Android programming, it works a little bit like the sensors in that. So, and they have thought of actually extending this a little further and making it so that you're not making it a little more abstract, again, like Android does. Like it has an interface that says, am I walking or running, that sort of thing, rather than let's talk to the accelerometer and get values, and then you have to do lots of maths to work out what's going on. One of the other interesting things around Mynewt is the packaging system. It actually is set up so that when you build something, you know exactly what goes into it, you know what all the versions are that have gone into it, and you can make reproducible builds. I don't know if anyone's had a lot of experience in this space in IoT, but often if you've got a device with some software on it, knowing exactly what that software is sometimes hard. In fact, sometimes it's impossible to know. And that makes testing really difficult. And it also makes diagnosing of issues and bugs really difficult. If you get a faulty device sent back to you and it's like, oh, I don't know what was on that, it's almost impossible to do that. So what they've done is they have a concept of projects and packages. So a project is a collection of packages, and all of these projects are released and versioned in repositories. So you can just store them in GitHub, and they can be put anywhere in GitHub. They don't have to be on Apache GitHub. They can be elsewhere as well. And you just have a little text file which describes which packages you're using and the version number. So it's sort of like a simplified version of Maven, I guess, is probably the easiest concept to do it. So it means you can take a package and reuse it across multiple projects, which is really nice. It means that you can pick and choose which packages that you want for a certain project. It also means that you can have different debug and release packages and keep them clearly defined so you know exactly what goes in which. And yeah, so they're not using make, which is the standard sort of C way of compiling projects. They have their own system built in there, but it's pretty easy to get used to and quite simple and straightforward. Here's sort of an example here. So this is the Mynewt core. This is saying that it's on GitHub. We want to use 1 point, whatever the latest is, and this is the repo to go have a look at there, and that's it. So that will know to go and get the code, and it will get whatever the latest released version is, 1 point whatever. But you can change that to say, just give me the latest in development if you're feeling risky. Or you can say, oh, no, we're just aiming at 1.1. We're not going to worry about this newer 1.2 version that got released, or the 1.7 or whatever, because you've tested against that. So it's sort of a nice feature. And this is showing a package configuration and how this is for a Blinky app. And you can see that it's got some metadata there that describes the package, the author, where it exists, and then the dependencies that it relies on. So if you include this package, you're automatically going to get the other packages there as well. So they're all core packages there. There's just the core OS, the hardware abstraction, and it also has a console. Console is really good for debugging. It means you can telnet into the device and do various things and look at error messages and stuff like that. So one of the reasons why they did this is that not all the packages have compatible licensing with the Apache license. While they talked to a whole lot of vendors and tried to get the license changed, some of them said no. So they said, oh, well, how do we solve that? Well, it's an optional dependency. We'll put it in a GitHub repo over here. And if people want to use it, they can use it, but it's not something that's core to the project. So the company runtime itself has several GitHub packages for things that are not compatible, and most of these are around the Nordic chipsets, and there's also the Adreno, a couple of Adreno boards, modern Adreno boards as well. So I'll talk about how this actually starts up and what goes in under the hood, and this is one of the more important things, is that there's a little tiny bootloader. And the bootloader, you can choose where it exists. It can either exist in ROM, read-only memory, or it can exist on flash. And generally what it does, there's several different modes, but the most common mode is that it boots up, it does a checksum of the image to check that it's all right, and if it's all right, then it starts. And the checksum can either be just a simple SHA-256, or it can actually be full digital signatures and all the rest. So you've got a choice there which path you want to go. Some constrained devices are not going to be able to support the RSA side of things. So that's it. So what you wanted to do when you're uploading this is the most common way of doing it, is that you create a new boot image, and that image gets signed, and then you've got some way of uploading it to the device. And it supports a whole lot of different methods that are actually built into Mynewt, and that can be update over Bluetooth, update over Wi-Fi, or update over a serial port. And what it'll do is that the most common way of doing it is that you have an A and B partition in your memory. You'll get the new image and load it to B. It's currently running A. It'll do the checksum on B. It will then reboot and swap those images, well, it just swaps a pointer really, and then runs up with B. If that works and is fine, it keeps running of it. If that fails, then it goes back to the old one. So it means that you don't actually brick a device, and it's you're just sitting there with something useless, which is a really good idea. So just a little bit on power management. It supports very deep sleep modes. Some of these devices you can put into basically a mode that consumes microwatts of power, and you can get it to wake up at certain intervals. That wake up task is tickless, so it doesn't actually consume any power when it's running. It's actually quite a clever little thing. And there's also networking sleep management too. So you can just basically say, wake up when there's any internet traffic on my port, and go and do what I need, and when there's nothing, then go back to sleep. And it can very quickly turn that on and off. So I mentioned before about debugging, and the fact that there's a whole lot of logging and statistics that are in there that are a great help that when you're writing these. So that logging statistics can either be written to RAM or flash, and it supports circular buffers. So it means you're never going to run out of memory. It does mean that sometimes the interesting thing that you're trying to find happened 10 minutes ago and that's been overwritten, but that's better than the device falling over and not working at all. It can also write core dumps out. So if there is a catastrophic failure and you do get a core dump, it can actually write that out to, say, the extra boot partition that you're not using. And then you can go download that and have a look at it and see what's gone wrong with the device. I don't know what people's experience are here, but often if you've got a device, you can't see what the software is actually doing on there. It's actually can be quite difficult to do that. And if it falls over or dies in some way, it's really hard to diagnose unless you've got some form of logging or some way of getting back from that. It also has stack guards, as I was mentioning before, that will protect you to some common Stack Overflow issues. And it also tracks memory over time as well. So you know how much stack that you've used up. So you can actually fine tune it a little bit. Does anyone remember the incident with Toyota a few years back where they had uncontrolled acceleration on cars and caused a couple of crashes and I think a couple of fatalities? Yeah, that was basically, if they were using Mynewt, that wouldn't happen. Right? They had a couple of serious issues. One was, how I remember it anyway, was that they were storing the bit that says the brake pedal was down was in volatile memory. They weren't looking after their stack space. Stack got too big, things got overwritten, Watchdog would reboot it, and then it wouldn't know whether the brake pedal was down or not, because that was in volatile memory, and it changed, and that's not a good thing. So there's also a unit testing framework, and you can actually run all the unit tests on your local machine. You don't actually have to run them on the device itself. Well, you can run them on the device as well. You've got a choice. So it's got that flexibility to, you can test quickly and on your own computer, and then you can actually test it on the hardware itself to make sure that it works. There's also a simulator as well, so you don't even need the hardware itself. You can actually run on Mac and Linux and develop completely off it, and you can get all the unit tests to run on that as well. So again, this just speeds up delivery and development time. And this is the bit that I've been getting to, is how big is it? I thought someone would have asked this by now, because that's usually the thing. It's like, oh, it's a real-time operating system, but yeah, it's going to eat up all my memory. The core of it is 1K RAM, 6K flash, and that's it. Now, that's the absolutely basic bits of it, and the more you use, the more that creeps up. So if you add the Bluetooth stack, a minimal Bluetooth stack is about 15K RAM. All of it is about 100K code. So that adds a little bit, but that's typical with other Bluetooth stacks that are out there. It's not exactly, it's not twice as large or anything like that. And for the number of features that they've got in that Bluetooth stack, that's actually quite a good size. Security is taken very seriously. There's a unique device identification API. So you can actually individually identify devices and what they're running and what's going on with them. I mentioned all the images are signed. There's a secure bootloader. It supports TLS as well. So you can actually communicate securely on there, and it also supports a number of mechanisms of Bluetooth security. I'm not going to go into a lot of detail on that. So what's new? Bluetooth 5 support and Bluetooth mesh support. So they've been added in the last year. The Bluetooth mesh stuff is particularly interesting. It also supports LoRa and LoRaWAN. Are people familiar with that? Yeah, it's one hand at least. So these are low power, wide area, long range networks. They're perfect for IoT type stuff. You've generally got a small base station which costs a couple of $1,000s, and then that can talk to 20 or 40,000 devices within a couple of kilometer range. So that's the perfect solution for this sort of things. The sensor framework has got a lot of work in, and there's more support recently for Cortex M7, so that's the more powerful Cortex chips, and a whole lot of other board support. They've added encrypted flash so that you can actually encrypt all the information in the flash drive there. They've added a battery sensor. They've added a true random number generator, and more boards. They're changing a little thing around the task system, which is interesting. They have this concept of task pools. So rather than having a large number of tasks that each wake up, you can actually create a pool of tasks, and it means that you can optimize the memory that's used there, so that it can you can have multiple tasks that share a same pool, and it's a nice idea. They've got Bluetooth 5 certification as well, which is good. And there's a few other features that they've added there, like more work on the crypto framework, generic bus driver, which is great. Yeah, got a question over there? Not directly, but it will. It can support them, because these days the sort of the API that you talk to the cellular network chips, it's a simple interface. It's generally just a serial interface, and you put AT commands, if you remember those. You remember typing AT+++? No. So back when you had modems, like you used to type a whole lot of commands to configure it and to dial it and so forth. That's basically what these things do at this level. So it's just like you're at a console and you just send commands to it to make it do stuff. It's pretty straightforward. So a lot of these electronic components have become more like Lego, and they're more like bricks that you plug together, and they have standard interfaces between them. And those interfaces may be lowish level ones, like SPI or I2C, or they can be slightly higher level ones, like basically a terminal interface or a console where you just type commands and make it do stuff. So I can show you some examples afterwards if you want to come and have a chat to me. Yeah, so it is possible to put 3G, 4G, 5G, whatever chips in there. Yeah, I've got one in my bag actually. I can show you. Anyway, so that's sort of what they've been working on at the moment, and work on the project is still going on. So if you want more information about it, there's a whole lot of links there. You'll be able to get these slides from the conference website. And I also actually have the slides as part of the Apache training project. I don't know if you know about the Apache training project? No? Okay. As we've got a couple of minutes, I might just... are there any questions first on any of that, on Mynewt? Do you think it sounds like an interesting real-time operating system? Yeah? Yeah.
So I'm not really
Yeah?
maybe a little bit naive but do you know of any examples of people working with ZigBee chips?
There has been some conversation on the mailing list using Zigbee. I quite like Zigbee. They're interesting. They've sort of been... There's more interest these days in the LoRaWAN stuff than there is in the Zigbee stuff. That's sort of what's replaced it, at a guess. But it still has its place. It's not... Yeah, I mean, Zigbee was originally very industrial. It's used in oil refineries and things like that. Yeah, some years back I was playing around with some Zigbee devices, and I accidentally discovered that if you don't set the addresses on them properly and you try to upload some software, you will actually do a broadcast and upload all of them at once, which is sort of funny. You had another question?
No, that was kind of the main point. So I work for ASF, and we primarily work with CPUs and devices. And I was just interested as to
Yeah, there are people. One of the first applications that Mynewt got used into was smart electricity meters, and I believe they used one of those two. I can't remember exactly which. So, any other questions? No? Okay, well, thank you very much for coming along to my talk and listening to me. I'm here for the rest of the conference, so if you want to talk about Apache Mynewt or the Incubator or anything in particular, yeah, come and see me.